Okay, this will be pretty short. This is just introducing another item in that list of ways to find the view factors, right? So we had gone through maybe 4 or 5 of them. There's a couple left that are pretty flexible and useful. One is the crossed and uncrossed strings method, and then the last one is the Monte Carlo technique, which we'll talk about later. The crossed and uncrossed strings method, though, is pretty easy to understand, easy to explain. It's only good for two-dimensional surfaces. So two-dimensional surfaces being surfaces like the ones I've shown here, surface 1 and surface 2, that extend a long way into the page so that they're able to be simulated or approximated as being two-dimensional, right? And the way the crossed and uncrossed strings method works is you go to the edges. So this is the edge of surface 2, the left edge, this is the right edge, and then this is the edge of surface 1, the left edge and the right edge. And you imagine drawing strings tight between these corner points, these edge points. So there's going to be a string that goes from the left edge to the left edge, that's the string AD, and from the right edge to the right edge, that's the string BC. Those strings do not cross, so those are our uncrossed strings. And then there's another set of strings that go from the left edge of surface 2 to the right edge of surface 1, and then vice versa. Those two strings obviously cross, right? And so it's the length of these crossed and uncrossed strings that allow you to calculate the view factor, and of course that's where the technique gets its name from, is the cross and uncrossed strings method. And the formula for that is down here, and it's just A1 F1 2, which is then, so the area of surface 1 times the view factor from 1 to 2, which by reciprocity has to be equal to A2 F2 1, is equal to W, which is the length into the page, times the sum of the length of the cross strings less the sum of the length of the uncrossed strings divided by 2. And of course this W doesn't actually matter because there's a W here in this part of the formula. There's going to be a W over here in these areas too, right? These areas will be times W, so W will cancel out, and you'll only be depending on the length of the cross and the uncrossed strings method. So in this case, the length of the cross strings would be the length of AC plus the length of BD, that's what I have here, and the uncrossed AD and BC is what I have here. And this is pretty flexible. It's geometry, right? Sometimes you have to be a little, you have to do a little more geometry than what I've shown here to really figure out these lengths, but in general it's pretty easy. It's really actually kind of cool because the techniques continues to hold even as other things start to get in the way. So if I start to move something into this, so for example, maybe I move a surface into this space, that surface is certainly going to affect the view factor from 1 to 2, and you would expect that the surface would tend to reduce it. And the way that you use that surface or include that surface in this calculation is you make the string that goes from the corners bend around that surface. So here you've seen that I can't just draw a string tight from A to D. If there's a surface in the way, I have to pull it around that corner here. So in that case then, if I go down here, what's going to happen? All the strings stay the same length except LA to D. So this is LA to D right here. I'm subtracting a bigger number. That means my view factor is going to go down, right? So that definitely is included in this calculation. So here's a real quick example. This is just an obvious case where you can use this. I have a plate here, and it's underneath this triangular cavity here, right? The left edge of the plate is here, lined up with the left edge of this body. The right edge of the plate is actually lined up with the center of the cavity. And I might want to know what's the view factor between the plate and the cavity, or the cavity and the plate. And to do that, if surface 1 is this cavity, then here's the left edge and the right edge. Surface 2 is the plate, here's the left edge and the right edge. And these blue lines then are our strings, and it's just geometry. I just go through and figure out the length of each of these strings, which I have right here, and I've gone through and done that here. And then the area of surface 1 is the area of this cavity, right? And that's where you see the W comes in. The area of surface 2 is the area of this plate, so there's a W there. So if I plug these equations into this equation here, I'll be able to calculate F12 and F21. All right.